Hello student, welcome to Destiny classes. Today we will learn the topic thermodynamics. Student, thermodynamics, it is made up of two words, therm and dynamics. Thermodynamics, which means the heat or energy, two Greek words, therm, heat or energy, dynamics, motion. We study the heat energy movement in the thermodynamics. So let's first talk about the system. Any object system. Object under observation is called system. Object under observation is called system. Suppose this is an object and we are going to study, observe temperature, pressure changes. So it will call as a system. The object which we are going to study, observe, it's called a system. And apart from system, it's called surrounding. Apart from system, called surrounding. So rest of the system is called surrounding. Called surrounding. And when both together, it's called universe. Universe. System and surrounding together, system and surrounding together called universe. Together called universe. Now, we will study the three types of system. Three types of system. First, we will see the student open system. Open system. A student open system, it means it can transfer the heat or energy and matter, energy and matter to surrounding, to surrounding. So let's consider we are boiling the water. When we boil the water, if suppose initially it is 1 liter or 2 liter, after certain time the water level will decrease because the water which will evaporate go to the surrounding. So we can say that the after certain time the water level decreases, it means the energy and matter transfer to the surrounding. So it called the open system. Open system. OS, energy and matter to transfer to the surrounding. We have the beaker, we have coffee, we have anything. So it can transfer the heat and matter to the surrounding, energy and matter to the surrounding. It called the open system. Second, we will study the closed system. Closed system. System which allow only which allow only to transfer energy. System which allow only transfer of energy to surrounding, to surrounding. It's called closed system. It's called closed system. So what we do, we are now putting one lid or cap. So it will restrict the flow of energy. So energy will lie inside the system. It will act as a closed system. Okay, student. It will not allow to the transfer of the matter. It will only the exchange. This is the conducting wall to the surrounding. To only allow the energy to exchange, not the matter. This is called the closed system. We have the third system. It's called isolated system. Isolated system. System which do not transfer energy and matter, energy and matter with surrounding, with surrounding. Now suppose we have the insulated chamber. This is the insulated chamber, the adiabatic wall, insulating wall, insulating wall, or adiabatic wall. Adiabatic, we do not allow the transfer of the heat to the outside, like thermal flash. Example, thermal flash. Till now, we have learned open system, closed system, isolated system, energy matter, we transfer both, closed system, we transfer energy, not matter, isolated system, energy matter, do not transfer energy or matter. Now student, we will learn the fourth law of thermodynamics. We will start from the scratch, laws of thermodynamics, laws of thermodynamics. We start with the first one, which is the zeroth law of thermodynamics. Zeroth law of thermodynamics. Okay, student. So it said that the if two body are in the thermal equilibrium, if two body are in the thermal equilibrium, thermal means temperature same, thermal equilibrium attached with another body, then after after certain time, all will be in the all will be in the thermal equilibrium. Thermal equilibrium. So suppose we have a body A, it is in the thermal equilibrium with body B, attached with body C, so all will be in the thermal equilibrium after certain time. So because the temperature will get transferred one body to another body. Now we will learn the first law of thermodynamics. First law of thermodynamics. First law of FLOT, it also said that thermodynamics. When we talk about the first law of thermodynamics, student, we said that the energy neither created neither destroyed. Energy neither created, neither destroy. So we can say that it follows the conservation of energy. It say about conservation of energy. Of energy. Energy of universe is constant. Energy of universe is conserved. It always conserve in nature. Just transform one phase to another phase. Conserve. Now, student, suppose we have a object which has the internal energy U1. We apply the heat Q. We apply some work W. So now this the final stage is internal energy U2. So U2 is equal to U1 plus Q plus W. So U2 minus U1 is equal to Q plus W. So change in internal energy delta is equal to Q plus W for the object. Now we have to know about the sign convention. Sign convention. Now for sign convention, heat added on the system. Heat added, something which we are adding. Heat added on the system. Positive. Heat released by the system. Heat released by the system. Negative. Work done by the system. By the system. Negative. Work done on the system. Work done on the system. Positive. These are the four sign convention we use in thermodynamics. Student. Now we move to the second law of thermodynamics. Second law of thermodynamics. Thermodynamics. So students, second law of thermodynamics said that entropy of universe always increases. Energy always transfer from higher energy state to lower energy state or if we have to transfer lower state to higher then we have to supply external source of it. External source of heat. Okay, student. Suppose we are boiling a water. So we have to supply so that it reach to the higher temperature. If a metal is higher temperature, it will get cool after some time. So it will transfer higher state to lower state. This is the second law. Energy always transfer from the higher state to lower state. If I have to transfer lower state to higher state, we have to supply the source of heat. So we will burn the source and we will get boil the water. So higher temperature to lower temperature, it will obtained by the container. Now another definition is entropy of universe always increases. Entropy of universe universe always increases for a spontaneous process. For a spontaneous process. Entropy also means the degree of randomness. Entropy is the degree of randomness or degree of disorderness. Degree of disorderness. Suppose this is a pattern like the universe at the initial state. So after the evolution, it follow the change in their pattern. So the pattern getting disorder in nature and the entropy tends to increase. But we will understand the practical way. Okay, student? So practical way to understand S is equal to Q upon T. Okay. So for entropy, we have to divide it by heat by temperature. So now suppose we have a water which is the 100 joule energy. 100 joule of energy, and we are supplying the temperature at 50 Kelvin. Okay, student. So for the entropy, S is equal to heat if it is the 100 joule. So this is the system. System having the heat 100 joule 50 Kelvin, and it will lose the heat to the surrounding. And just 50 Celsius you can also consider, so we will understand it very clearly. So if entropy as measured in Kelvin, but we are just writing for understanding. So entropy 100 joule it will change to the surrounding. So heat release minus 50 degrees Celsius. Okay, so entropy is minus 2 joule per Celsius. Okay, students. So this is the unit. And now we see that here the cold wind in the surrounding. So 25 degrees Celsius room temperature. Okay, student. So the heat system to surrounding taking place. So we will say that this is the entropy of system. Entropy of system. And entropy of surrounding. So again Q upon T. So again Q is how much? The heat released system to surrounding 100 and the cold temperature 25. So this is the 4 joule per Celsius. So we are just making the simplification for the cold bill. So now the S universe. So universe is a student system plus surrounding. S system, entropy system plus entropy surrounding. So student, minus 2 plus 4, we get the plus 2 joule per Celsius. So we can see that entropy is increases or positive for the spontaneous, means we having the coffee, it naturally get cold. So that's why the entropy of the spontaneous process increases or greater than 0. Now we will understand the third law of thermodynamics. Third law of thermodynamics. It says about the student, for a perfectly crystalline substance, for a perfectly crystalline substance, entropy tends to 0 at 0 Kelvin. So limit T tends to 0 Kelvin, entropy is equal to 0 for a perfectly crystalline substance. But even some of the molecule like CO, NO, they show some kind of the entropy even at 0 Kelvin because they form like NO, OM, NO. So they have the dissimilarity in their pattern COOC, CO. So this is all for the today session, and we will meet in the next session more kind of concept, and join our crash course, target course, join the test series. Do call for all updates and like and subscribe the channel. Thank you so much, and do call for any query. So this is all. Thank you.